Welcome to my Graphics Assessment 2 submission. For my submission, I focused on replicating the unique art style of Lucas Pope's Return of the Obra Dinn. Right, let's get started. So, perhaps the most defining feature of Return of the Obra Dinn is its unique one-bit aesthetic. The two primary parts of the shader are the outline and the dithering employed to blend between surfaces, light levels, and depth. Because of this artistic decision, geometry is simple to keep the environment clear and readable. And to simplify things further, almost all of the game's meshes are static. The only exception to this rule are the sails and ropes, which gently sway in the wind. And of course, the rendering resolution has been drastically reduced to complement the one-bit shader. Lucas Pope describes the shader in his development blog. He mentions that he uses 3 passes for his shader, one for defining surfaces, another for defining shadows and textures, and a final pass for combining the two and applying the outlines and dithering. Originally, Lucas experimented with a traditional use of a Laplacian filter to detect edges applied to both the normal and the depth buffers, and then adding the results together. However, with some experimentation and testing, he found that this approach was inaccurate under certain circumstances. In place of this approach, Pope leveraged the normal and position information of each surface to colour each surface a unique colour, which was then used to define the edges. And this is visible on the top left image. The second pass uses Unity's built-in lighting buffer to store lighting information in the red channel. Texture information for the meshes is stored in the green channel. The blue channel is unused. And again, you can view the result in the top right image. The last shader combines the two and processes them into a final output. The outlines use a red lighting channel to determine their colour, whereas the texture is processed using blue noise dithering. Geometry also uses a level 3 or level 4 Bayer dither to add depth to objects. I'm not actually too sure which it is, but I'm pretty sure it's level 3 or level 4. I identified several issues with implementing the shader before starting my implementation. First of all, Unreal Engine doesn't have a lighting buffer, apparently, for performance reasons, which makes replication of the hard shadows impractical, as well as the different what do you call them again? Outline colours. For this reason, I instead relied on processing the camera's content after tone mapping. Secondly, it's common to a lot of game engines, but there is an issue with macOS and the way it handles DPI scaling. So the dithering I applied was a bit troublesome to scale up. I'll discuss that later. This is a scene that I created in Unreal Engine. The pirate ship was a part of Cinti's Pirate Asset Pack, and the water is from the Experimental Water Project. The Experimental Water plugin, sorry. Yeah. Right, so I'm going to perform a comparative critique of the scene now. So my scene, well, let's discuss the, I suppose let's start with the sky and water first. So, actually no, let's discuss the dithering first. So my implementation uses a simple level 0 dithering as opposed to the level 3 or 4 dithering, primarily because of scalability reasons. It becomes a lot more complex to process the dithering the more levels you add to it. So I just did a proof of concept level 0 dithering, level 0 Bayer dither, mind you, which I think it looks good enough. But that is room for improvement I'd like to expand upon in the future. The lack of outline changes is a result of the fact that Unreal Engine doesn't have a shadow buffer. I looked online and it was addressed by a staff member. Apparently, you can implement your own shadow buffer, but it'd be pretty what's the word? It'd be a fixing up job, and it's just not. It's not recommended for production projects. Yes, discuss that. Sky and water. So the water, obviously there isn't this much. The water and the sky looks drastically different to the original, primarily for stylistic reasons. So the Unreal Engine doesn't have a blue noise. Doesn't natively support blue noise, which made implementing the stylistic water and sky difficult. So in place of that, I just used Unreal Engine's assets, which I think it actually adds a bit of depth there, although it does make it a bit more difficult to read the environment, so that's definitely room for improvement. I forgot to mention this in the last slide, but another issue I had was tweaking Unreal's lighting in graphics to really get something similar to Return of the Obra Dinn. Because of all the post-processing they add to the scene by default, it's difficult to strike a good balance between light and dark. So that's another issue I had. Right, implementation. So the outline uses a Laplacian filter on the normal and depth buffers. This is what Lucas used in his original implementation, and whilst he had issues with the way he was using his scene, I didn't have issues like that, so I decided to keep it relatively simple. So I just used the Laplacian filter. As already mentioned, dithering uses a level 0 Bayer dither. You can see that on the bottom there. There's also the code snippet from the custom node there. The way the custom node works, you'll notice that it creates it performs a modulus operation on the y coordinate and 4, not 2. I don't know why Unreal Engine does this. If I set those 4s to a 2, you don't get the dithering effect. It just goes all white or all black. I don't know quite what's going on there, but I assume it's got to do with the pixel scaling issues I mentioned earlier. I'm using macOS to do this project, and the pixels are scaled incorrectly because I'm using a 2 times DPI scale on my laptop, so that's probably where that issue is coming into play. And then let's go here. Right, so the way the interaction system works, it uses a... so I create an interaction blueprint class, an interactable blueprint class, that's on the bottom. That basically switches out the material, which is the top image. The material has a parameter called canInteract, and if that's true, it displays an animation, a simple switch statement, a simple remapped sine wave animation. And once interacted with, the interactable blueprint has a variable called dialog text, which is passed into the dialog blueprint widget as a public variable, which is then used to display the text you see when you interact with it, and then after 5 seconds it removes the text. Finally, I'll leave you with the the showcase. It's just over a minute, so yeah. Thank you for watching this video. See ya.